Hello everyone and welcome back to another Fusion 360 live stream. Today we are going to be talking about advanced sketching techniques. This is going to be part 2 of our two-part series on sketching. Last week we did part 1 about the basics or fundamentals of sketching. Today we're going to be doing some advanced sketching and I hope you're looking forward to it. We have Brad on the keys, and I'm Jason from the Fusion 360 team at Autodesk. And let's jump right into what the agenda is for today. So on the screen right now, you could see that I have a huge list of things we're going to cover. Quite a few things. My goal is to go through this exact list in order, and after this live stream is done, I'm going to go and put this in the description with a link to the exact time for each of these items. So if it turns out you're only interested in one of them, you should be able to find them pretty easily. But again, this is going to be a lot of stuff, so let's get right into the good stuff. So we're going to jump right into Fusion, and we're going to start off with the first item, less is more. And so we showed you at the first live stream about sketching, about how you could actually create your geometry. And now we're going to try to hone in on the details of like getting better at it. Remember, I told you last time that if you're having trouble or struggling in 3D, it's possible or even likely that it all starts off with your sketching techniques. So we're going to try to get you incredible. We're going to try to get you to top level sketching, and we're going to hopefully use these techniques to get there. So the first one is less is more. So let's look at, let's say, this sketch that I have here at the beginning of this particular file. By the way, this is a vacuum form package for a part, and this is actually a template, so you can adjust it automatically. And I opened the wrong sketch. Let's open the right one. And here you could see I have a sketch and it has some detail in it, but what I'm going to try to tell you is the first thing you should consider is that less is more. The less you have, the better, because it's going to not bog down your system. It's not going to take as much time to calculate, things like that. I'm not saying to get rid of a whole bunch of stuff that you actually need. I'm saying to really consider what you need and what you don't. And so this is actually a good example of bad practices. So I have a model here that's clearly symmetric left to right, and also clearly symmetric top to bottom. And so ideally, I would actually design this as a half, and then once I'm done, I mirror it. Or I actually design it in a quarter, and then I mirror it across, and then I also mirror it below. So just so you want to try to do less if possible, and also try to design using symmetry to your advantage. So try to design a half or even a quarter of your design whenever possible. So the same design that we're going to actually work on together, I'll show you in another file. And this is what I do recommend you put in here. So you have just a quarter of your design, and when you're done, again, you're going to mirror this across to the right side, and then also mirror this down below. But you don't have to mirror it as a sketch. You can actually mirror the solid body that this is going to create, and that would actually end up being far better for you. So less is more, and design as little as you have to, right? So a quarter or a half would be great. The next one I want to talk about is dimensioning based on other dimensions. So let's jump right into this particular sketch. Go and edit this sketch. And right now you can see I have no dimensions in this model at all. Let's go and start to add some of these dimensions. First thing we could do is we could measure the actual part that we're going to be trying to fit in this vacuum form tray. And it looks like it's 37.5 millimeters across. I think I measured that incorrectly. Let's try that one more time. Measure from there to there. And that looks like it's 38 millimeters actually. So let's go and measure from here to here. And this will be 38, but we want some clearance actually. So we'll go and add, so we'll say 38 and maybe add an extra millimeter of clearance. And then left to right, we're gonna do the same thing. Let's go and zoom in here, measure that edge, measure this edge. Distance is 37, so it's a little different. We'll go and measure from here to here, there we go. And that'll be 37, and we'll add a millimeter for clearance. Perfect. Now, what if, for example, instead of this being based on an existing part, what if you wanted to model this yourself, right? This would be pretty straightforward. I have this as 39 millimeters. I have the other dimension as 38 millimeters. And where it gets really interesting is that you don't have to just put in a dimension every time. You can actually reference other dimensions while you're in the same sketch. So what if I wanted these to be equal? And I know that right now they're not equal and that's on purpose. But if I did want them to be equal, I could use some constraints, like I could grab this equals constraint that we talked about last week, and I could set this line over here to equal this line, and that would make them equal in width. But the other thing you could do is you could make the dimensions themselves equal. So watch how we're going to do that. I'm going to double click this dimension, and you'll see here that I have my input. And I already kind of skipped ahead. I put in an equation here that we'll talk about in a second. But let's say I put in a number, like this is 35 or 34, whatever number you happen to want. Where it gets interesting is that if you highlight over this dimension, you'll see that underneath my arrow, it says D4, the D stands for dimension, and that D4 is equal to 35 millimeters, which makes sense because I typed in 35. But if I hover over this one, you'll see that this one is D3, right? And it says that D3 is equal to 38 plus 1, which happens to be 39. Now, when you go to type in a value, instead of typing in a number, you can actually type in a dimension. So you could type in D3. Remember, this one over here was D3, and I hit enter, and it'll automatically make my correct number. And you'll notice that it actually puts in a little fx. The fx stands for function, if you remember way back when from math class. And it says that this function is that D4, that's this dimension, is equal to D3. And that's how it ends up being 39. So if I change this number from 39 to 45, let's say, it's actually going to go and update the other number as well. That's where it gets really interesting. Now, you don't have to just hover over things, figure out what the dimension is, and then input it somewhere else. You can also just type it out. So let's go and delete this dimension and let's create it from scratch. And I'm going to go and drag this a little smaller just so you can see a visual change here in just a second. All right, so there we go. So let's go and put a dimension. I go from this line to this line, click a third time to go and put in a number. But instead of typing in D3, I'm actually going to go and just click on this dimension. And it automatically grabs whatever the dimension number is, which happens to be D3, and lets me put it in there. So you can type in that value, or you could just click on another dimension, wherever it happens to be on your screen, and it'll input it right in there. So that's pretty awesome. Where we're going to take it a step further now is talking about dimensions based on equations. And like I said, I accidentally spoiled the fun a little while ago by typing in a number and then +1 for my clearance, right? But you can do that not just by adding clearance, but also by having equations based on those other dimensions if you want. So what if this number here, I want it to be equal to D3 divided by 2. So whatever that number is on the left-hand side divided by 2, plus some other number. Now, if you remember from math class way back when, there was that theory, I believe it was called PEMDAS, right? Parentheses, exponents, multiplication, division, addition, and subtraction, right? So that order is important. And to help Fusion be able to do this easily, I think using parentheses is a great way to do that. So if I just type in D3 divided by 2 plus 1, it could give me exactly what I want. But if I want to just be safe, I could go and put the D3 divided by 2 in parentheses. And now it's going to go and divide that dimension, D3, which happens to be 45, divided by 2, and then in this case, add 1. Let's see what happens. And it tells me, again, this is a function based on some other dimension or some other number or an equation, and that the resulting value is 23.5. Again, it's based on this one. So if I change this from 45 back down to, let's say, 40, I'm going to get a different result here, which happens to be 21. So far you've seen that we can dimension off of other dimensions, and you can also put in equations. And you can make these equations pretty complex if you want to. Just be aware that you can do that. Now, where it's going to get even more interesting, at least in my opinion, right, is going to be something called the parameters table. So let's go and look what that parameters table is, where I can find it, and I'll explain a little bit more detail. If you go up to the modify menu and you go to the very bottom here, you'll see change parameters. And I use this often, so I actually added a shortcut to it. And so I can get there by Control P on my keyboard. We'll go and open that parameters table, and this is what it looks like. Right now it is empty, so nothing particularly useful in here. But I'm going to show you how we can add stuff to this parameter table and then how we can use it from those dimensions that we talked about. So let's go and add one here. This is going to be called, let's say, part width. And I'm going to set this to be, let's say, 50 millimeters. Then I'm going to go make a new one here that's going to be called part length. And this one's going to be called, let's say, 35 millimeters. And then maybe I'll also make one here that's going to be called part thickness. And we'll make that 15. Now, keep in mind that your name has to be, oh, and I spelled that wrong. Your name has to be one word. It cannot have like spaces in it. So if you do want to have spaces, you could use underscores. So it could be like part underscore thickness if you'd like. And I will also caution you that if you like to type in, you've probably seen in my other videos, that you can type in a number and then IN for inch, or you could type in mm for millimeter. So regardless of what your units are, you can type in whatever number it is, and as long as you add that unit at the end, it'll automatically put in the correct number. But just be a little warning that if you have in your name the letters IN, when you start to type in something later, it might not be sure, at least at first, whether or not you're talking about one of these parameters or IN for inch. And I'll show you that and what we're talking about in just a few minutes. So here I have part thickness. We're setting that to 15 millimeters. Oh, before I hit OK, you should also know that we have a lot of different options for units, like a lot of them, not just for length or angles, but we even have things like currency and current, luminosity. I mean, there's a lot of really good stuff here. So take a look at that in more detail when you have some time. You could also, by the way, put comments here, which help you like keep track of like what's doing what and things like that. So I have a couple of parameters. Oh, let's add one more. Let's add a gap. Let's go in here. We'll call this gap. And from before I had it as millimeters, so let's go and set it to be the same. So I have this list of parameters. The parameters are just things that you are going to reference on a regular basis. So in this sketch, maybe I want to have the dimension of this width to be based on the width of the part that's actually going to fit in this area. So I could double click here. Let's clear out that original equation that I had. And this is where I would just type in a number, but instead of typing in a number, we're going to start to type in part. So P-A-R-T, and you'll see that I have three options here. I have to move a little bit, my camera's in the way. And I have part length as the option. I'm going to just say that this is length. You might want to call this width, but I'm going to call this length. And when I click on this, it's going to put in that exact word. And when I hit OK, it's going to use whatever the value is from that parameter table. And again, it's going to show fx for function, and it's based on that parameter table. And I'm going to do the same thing over here, and this is going to be called part width. There we are. But we're going to make this even more interesting. We're going to add our equation as well. So it's going to be part width plus gap. Perfect. And then this one is actually going to be part length plus gap as well. Excellent. And then lastly, we're going to go and put in a dimension for this fillet, and we're going to go with 5 millimeters for now, something like that. So the general idea here is that these dimensions are based on the parameter table, and the parameter table gives you a convenient place for you to be able to make changes, not just to this sketch, but any sketch you're using later, features that you're using, patterns that you're using, pretty much anything in your model. So an example that I like to show people for parameters is a table, not a parameter table, but like a real table that you might use. And I have one here that I really like to show people. This is an IKEA style table that I designed here in Fusion. And you'll see here that this table has multiple components. It has screws, it has holes for those screws. It has a whole lot of stuff going on here. And if I go to that parameter table, you'll see that I have a list of all the things I care about most for this table. The thickness of the wood is 1.5 inches in this case right now. And I could set that to, let's say, 3 inches. And in just a second, my entire model updates. The length is 61 inches, maybe we'll make that 72. The width is 34, maybe we'll make that 45, and the height is 32. I like that. I'll leave it. So the idea is you have one convenient place that you can update every sketch in your entire model, every feature in your entire model, and you can reference this anytime you want. You can remember, you could put those equations in the dimension as you're creating it, but you can also make your equations right here as well. So you can make a new parameter that might be something like, spacing for screws. And the spacing for the screws could be based on the width of the table divided by some number of screws that you want, plus some extra gap that you want, or whatever that equation happens to be. You can put that right here. And then when we're doing patterns in just a little while, I can reference this value for like the spacing of my pattern or whatever it happens to be. Cool. So far I showed you dimensions based on other dimensions, dimensions based on equations, dimensions based on parameter tables, and let's talk about fractions. So you'll probably notice that when you're putting in dimensions into Fusion, we use the decimal system. So it's like 4.0 inches or 4.0 millimeters, 4.125 inches or 4.125 millimeters. We're not really doing 4 and an eighth, but you can. So the way that would work is, let's go back to our template here, and wrong file, this one, there we go. And if I want something to be based on a fraction, all I have to do is type in an equation that includes the fraction. So let's actually give a better example. No, this example is fine. So if I want to go and change the width here, and I want that to be 50 and an eighth, I would simply type in 50 plus, and then I like my parentheses here, 1/8, enter. And that'll be 50.125 in decimal form. But remember, I can input this as 50 and an eighth by turning and an eighth into an equation of plus 1/8. So that could be pretty handy. And this comes especially in handy when we're talking about using the imperial system for feet and inches, or inches and fraction of an inch. So let's go and look at a practical example where I definitely use imperial. Here you could see a floor plan, and this is a floor plan based on a blueprint. So let's go and turn on a canvas, and you could see that I have a full blueprint of a property that I might be designing or building or modifying, whatever it happens to be. And this is all to scale. I've already calibrated this canvas, which is great. And let's say I'm in the sketch. Let's go and edit our sketch here. And let's go and show our dimensions. There are a lot of them in here for the record. And I want to have a dimension from, let's say, this wall over here to right over here, this edge. And it says on the drawing 15 and 6 inches, or 15 foot 6 inches. I'm going to again put this in the form that I want to see it for an equation. So 15 ft for foot plus 6 in for inch, right? Hit enter, and that's going to give you exactly what you want. Right, so this is a great way to be able to do fractions. Keep in mind, of course, that it's still going to show you in decimal form because that's how Fusion is based, but you can input fractions. So again, this is handy for like 15 foot 6 inches. This could also be handy for 15 foot 6 and an eighth of an inch. I would just modify this to be 15 foot plus 6 inches plus 1/8 inches. Oh, and something I have here in my equation's wrong. Let's go and put this parentheses, I think. There we go. Something's a little funny here. I'm not sure what I'm doing wrong, but I hope you trust me on this. You can put in fractions anytime you want. So it's 15 foot plus 6 plus 1/8 inches, right? So that'll be an easy way to be able to get your inches and your fractions. So now let's talk about some other ways you can have your dimensions. And then we're going to move on to totally different topics that are still advanced sketching related. Let's go back to our tray example. Let's say I wanted to have a dimension for a diameter, right? I'm drawing a quarter of this particular tray, but I want to have a dimension for the total length. So what I would typically think, people that are newer to Fusion would probably try to do is they would try to use my example about equations. And if they wanted this to really be like the total length of the part to be 500, they would just say 500 divided by 2, and that's the like radius of this particular area of the part. That makes sense. There's nothing wrong with that. But if you do want to have the dimension be a diameter, what you would do instead is, let's go and delete that diameter, the dimension there, is I'm going to go and select this line and then this line. And before I select the third time to actually put in my dimension, I'm going to right click and I'm going to go and see here diameter dimension as an option. I click on that, and just in an instant, you'll see that the dimension is actually going from this line all the way across my center line. And now I could type in the value for the actual diameter, and it'll give that to me. And this is very similar to just putting in the radius, but I like visually seeing that this dimension is the correct dimension. I don't have to have any equations in this case. This is exactly what I want. I'll do the same thing to the other side. So we're going to go and pick this edge and then this center line, right click, and then do diameter dimension. And you'll notice that I have this going the wrong way. So what did I do wrong? The key is that you have to pick the center line first. So let's go and do this one more time. I'll hit escape to get rid of that. Perfect. So click the center line first. And by the way, it does not have to be a construction line. So pick the center line, pick the next line, right click again and hit diameter dimension. Move the mouse for it to actually update the preview. And now it's going to give you the preview, and click that third time so that you can actually input that value. Oh, that was way too small of a number I think I put in there. Let's try this again, 250. There we go, that's what I wanted. So that's a great way to be able to get diameters that you might not have seen before. Now there's another dimension trick, and then we're going to move on to other things, and that's going to be tangent dimensions. So let's say I have a hole that I need somewhere in this model. And let's go and go and move this out a little bit. And maybe I want to have a hole somewhere around here. And I want to have a dimension. Actually, let's line this up nicely. So let's go and put in a line, something like this. We're going to go and put this circle on this line. We'll make this line construction. And we're also going to set this to be a 45 degree, something like that. 45 degree. Okay, so now I have this the way I want it, but I don't have my dimensions at this point. So this is still free to move. It's not fully constrained. This circle is also not centered, at least not yet. And I want to, maybe I don't want it centered. Maybe I just want to pick what the dimension is between this fillet and this circle. Now the typical way you would do this is you go to your dimension tool, you pick the circle, you pick the arc, and what you're going to get here is a dimension between the center of the arc and the center of the circle, right? And that was, for the record here, even picking the arc itself and the circle itself. Not that I didn't pick the center of each. It automatically gives me the center of each. Now I could, of course, pick the center of each, right? I can go to the dimension tool, pick the center of the circle, pick the center of the arc, and it's going to give me the same thing. But again, what I did a moment ago was pick the circle itself and the arc itself, and it goes center to center. I can dimension it along the angle here that you could see, or I could dimension it vertical, or I could dimension it horizontal, but it's really center to center. And what I care about is having enough material between these two things. Really? So what I want is a dimension from this point right here that doesn't exist to this point right over here that doesn't exist. Now you can achieve this using just regular geometry. I can go to create, point, and I could put a point right over here or close to this area and another point over here. Then I could use my constraint like coincident and snap it to this line. Do the same thing over here. Now I have points that I could actually put a dimension on. I could dimension from this point to this point, and now I get exactly how much material I have in between. That's pretty cool. But what's even better is saving myself time and not having to do all of that. So I'm going to delete everything that I just did. So let's go and delete that point, delete this point. All right, so now I'm back where I started. Let's try this again, and we're going to show you the trick for, not diameter, for tangent dimensions. So I'm going to hit D on my keyboard for dimension. And before I click on the arc or the circle, I'm going to right click, and I'm going to choose here, pick circle/arc tangent. You'll notice that the default is pick circle/arc center, which is why it went right to the center. But I'm going to choose tangent. I'm going to choose the circle. I'm going to choose the arc. And you'll see here, it automatically is going to give me a dimension between them. And this is going to be the closest point between those two objects. So this is super helpful. I use this all the time. If you are newer to Fusion 360, then this is a great tip that I hope you enjoy. All right, so we covered a lot of dimensioning tools. Now let's talk about some other things. This is going to be a little bit more random of what we're going to cover in particular. And what we're going to cover, the next thing on the list was setting up canvases. Now, you've probably already seen that you can bring in a canvas, you can calibrate the canvas so that it's the correct size, and then you could draw on top of the canvas, kind of like tracing an image that's already on paper. But what you might not have considered is that you could bring in multiple canvases to make your life a whole lot easier when you're creating your sketches. So let's go and look at an example. So this example here is a Porsche or Porsche, depending on the pronunciation you prefer, and it's a 911, and that pronunciation should be correct regardless. So I have my Porsche or Porsche, and this was created using T-splines. One of my colleagues, Tyler Kirkera, whom you've probably seen in a live stream just a few weeks ago and a few weeks before that, Tyler designed this using T-splines. And this is a fantastic model, I have to admit. It still needs the details of the wheels and a whole bunch of other stuff. But from a general shape and form, this is beautiful. And how did Tyler actually create this? Well, let's go and look inside his model here in his canvases, and you'll see that he starts off with a side view picture from the internet, pretty straightforward. But he also brought in a top view, and he also brought in a front view. There we are. Now, the reason he brought in all three views is that depending on what he's designing on this vehicle, he might end up wanting to make a sketch from the front, or he might want to make a sketch from the top, or he might want to make a sketch from the side, right? It all depends on what he's doing. If it's a wheel, he might be designing it from the side so that he gets the shape of the rim. If it's the headlight, he might be designing it from the front. And if it's the roof or sunroof or something like that, he's probably going to design it from above. So what he did here is he brought in three totally different images. He brought them into the correct plane, right? So the front, in this case, is on the YZ plane, the right is on the XY plane, and the top is on the XZ plane in this particular case. So he brought in each of those canvases, and then he calibrated each one, and then he positioned each one so that they line up with each other, right? So the idea is that if I'm looking at this from the front, the very top point right here should be the same as the top point from the side view, right? And that should be true with pretty much everything in this. And it doesn't have to be perfect. Remember that the canvases are really just trying to give you a backdrop so that you can help draw, and your drawing should be the most accurate thing out there. But just know that having three canvases like this is a great way to be able to design your parts, especially when you're doing things like reverse engineering. This is a great example of that. So that is bringing in three different canvases. The next thing we're going to talk about is bringing in files from external sources, in particular 2D files or 2D vector files, not canvases. Canvases are typically bitmap images, right? They're pictures made up of dots. Vectors are going to be files that have lines and arcs and circles, all the kinds of things that you would create in your sketches in Fusion. Now, you could bring in three different file types for, actually, there's probably more, but the three main file types for bringing in to Fusion for 2D vectors are going to be DWG, which is the AutoCAD format that's incredibly popular. It's almost generic at this point because a lot of other places are using it, but it is an AutoCAD format from the start. You also have SVG, which is pretty popular, and then DXF, which is pretty popular. And each of these three file types comes into Fusion in a different way. And I'm going to show you what those are, and then I'm going to show you my personal recommendation for the best file type to choose and the best way to bring it in. So let's go and start off with the data panel. And the data panel is where you go and you upload new files. And so you can go and select new files to bring in. And we're going to go and look here at my list here. And you'll see that DWG is in the list right over here. And then if I scroll down here, I'm not seeing, I do see DXF and I see the DWG. So those two are there, but I don't see SVG. So if I want to bring in a DWG, I could do that here. If I want to bring in a DXF, I could do that here, but I cannot bring in the SVG file here. All right, so just a word of warning, so to speak, on that. You can also do the same thing via the File Open menu. So if you go to File Open and you go and say, I want to open something from my computer, you're going to see the same file types right over here as well. So you're going to see the AutoCAD DWG file, and you're also going to see the DXF file, but you're not going to see that SVG. Now there's another place that you can bring in files, at least for the 2D vectors. So that'll be under Insert. And here you're going to see a slightly different menu. You're going to see Insert SVG. So this is the only place you're going to be able to bring in your SVG. But you're also going to see Insert DXF. And DXF is both here and also under the File Open or that data panel. Now, depending on which of these file types you choose and which format which method you use to bring them in, you're going to get slightly different options. So if you go to the file open or the data panel and you just bring in the DXF or the DWG, you're not going to get any options. It's just going to go and import it. And for any file type that is unitless, like an STL file or SVG isn't on that option, DXF option, a DXF file format, or maybe a OBJ format, the units that Fusion uses by default is going to be centimeters. So a 1x1 box that's like a mesh file that's an STL or a DXF, it doesn't know if it's a 1x1 inch, 1x1 feet, 1x1 millimeter. And if you use that file open method, it's going to just assume it's centimeters, and that might not be correct for you. So my personal preference is to always use for DXF and SVGs whenever possible for like bringing in files. I like to use this insert menu. And let's go and look at SVG and let's look at DXF. Let's go and start a new file here. I'm going to go and say insert an SVG. It lets me pick a plane to show here, and it lets me bring an SVG from my computer. Let's go and grab one. And here I have a sheet metal part as an SVG. And you could see that sheet metal part right off the bat. It gives me some options here for like the position of this, like left to right, up and down, and a rotation. It also lets me scale this file right off the bat if I want to. And it lets me flip the file. In this case, it's symmetrical, so it won't show you anything different. And vertical, and again, it's symmetrical. And it does let you have this option here for control point frame, which is going to help you be able to make some changes to your more organic shapes. And I'll show you a little bit more about that when we go and insert our DXF in just a few moments. But these are the options. And you'll notice that at no point here did it happen to ask you what the units are. So it is making an assumption on the units, and you can scale this here. But if you want this to be truly exactly the right size right off the bat, then I do recommend you use DXF as your import option. Let's go and take a look at that. So I'm going to go and hit OK. You can see that I have my sheet metal part. I can use this for a variety of different things. But in this case, we're going to go and do this again using DXF as our option. Let's go to New Design, Insert DXF this time. I'll choose a plane. I'll choose a DXF itself. And let's go and grab this one right here. And now you're going to get similar options, but more options. My favorite thing are options. So you're going to see right off the bat that it asks you what the units are. This is important because you might be designing this in inches. You might be designing this in millimeters. You might be designing that original DXF in feet. So you choose whichever units you were using. So I might have been using millimeter, and it'll rescale this file accordingly. It does let you change that X position or that Y position, just like the insert SVG. But here's some other cool stuff it lets you do. It lets you see layers. And this depends a lot on where this DXF is coming from, on whether or not Fusion is going to see the layers and how it's going to see or how it's going to interpret those layers. But here you can see I have multiple layers. And let's turn off most of them for a second so we can look at them one by one. This is the outer profile, like the overall shape of my file. The next one is internal profile, so any kind of cutouts, which in this case happens to be holes, right? Some holes on this sheet metal part. This bend is going to be the center line of my bends. And then bend extends happens to be the start and the end of each of these bends. Now, depending on what I'm trying to do with this particular file, I might not care about the bend extents. Maybe all I care about is the center line of the bend. So by unchecking this box, I just don't have to import it, right? It just makes it easier for me. I could also import it and then go into my sketch and delete it, but instead I just don't have to bring it in at all, which is pretty helpful. And now I could go and say, okay, and I have my sketch, and I could turn this into a 3D model pretty quickly and easily. I could also, by the way, edit this model. So I can go into this sketch by editing the sketch, and I can go and drag this line wherever I want. You'll notice that this line is not connected to the top and bottom. And the reason is because this line does not have any constraints whatsoever. Right? All these constraints that I taught about last week about equals and coincident and horizontal and vertical and all that stuff, none of that is in here right now. So if you want that to be the case, if you want to have constraints, you would have to go and add them. So in this case, let's go and undo my move. I might add a constraint, for example, that makes the top of this line coincident with that circle. Maybe the very bottom here is going to be coincident with that circle or arc. And then I could also add a vertical constraint to this line. Now, when I go and I move this, it's actually going to, well, in this particular case, it's actually going to try to move this circle, right? Because I didn't constrain the circle or that arc. So this is good or bad, depending on what you're trying to do. So another trick is that you can fix any of your geometry that you want. And there is a constraint for fix, and you'll probably notice that in my last video, I didn't talk about this constraint at all. In my opinion, the fix constraint is a little bit more advanced, so I saved it for this week. So what I could do here is I could actually choose to fix this arc. You'll notice that it turns green. The green is telling you that this is fixed. Then I can go and do the same thing with this one. And because I added my constraints to the line between, now I can actually move this line left to right, and it's going to move based on the constraints, but it's not going to mess up those arcs because those arcs were actually fixed. And we're going to talk a little bit more about the fixed constraint in just a little bit. But this is one of the handy ways you could use the fixed constraint as well as, add additional constraints to be able to move this around. Now, if you like this data, you don't want to accidentally move things around and mess everything up like this, right? Because this could be really annoying if that's not what you exactly wanted to do. When you import a DXF or any other imported geometry, what you might want to do right off the bat is actually select everything in that imported geometry, right-click and hit Fix, or use that constraint from the Constraints menu. And now everything in here is fixed, and I won't accidentally move any of this geometry. None of it's going to move by accident. So that's another useful use of that fixed constraint. So remember, though, that when you bring in these imported vectors, they could sometimes have problems. They are not always perfect. Surprise, surprise, right? So let's talk a little bit about imported vectors and what happens with them. And we're going to start with a pretty commonly brought in vector, or at least a vector that's brought in from a common program. So let's use Adobe Illustrator as our example. So I'm going to go and bring up Adobe Illustrator. And here you could see I have the same exact file that you saw a moment ago. And this right now is an AI file. And we're going to go and save this as a DXF because remember, I just said just a second ago that I recommend bringing in DXF files. Now, the way you do that in Illustrator is you go to Export As, and then you choose here, you could choose DWG if you did want to bring in a DWG file, but I'm going to choose DXF because that's my recommended. And I'm going to go and overwrite this file that says AI to DXF, and we'll go and bring that one into Fusion. Now, before I go and show you what it looks like in Fusion, oh, and by the way, here it's going to ask you your scale. Remember, DXF is unitless. So this is telling you when you save the DXF, what units are you essentially, it's not exactly assigning it, but like setting it to so that it's correct. So in this case, it's the scale is 1 inch is going to be 1 unit. This is going to be really the 1x1 box that I talked about earlier, like, the 1x1 unit. We're saying this is inches so that when we import it, we'll also choose inches. Right. Let's go and look at something in particular. Now, this is going to be important because we're going to talk about the circles when they come into Fusion. So if you look at this circle in Illustrator, you'll notice that it has a point on the top, a point on the bottom, a point on the left, and a point on the right. And the reason is because even though this looks like a circle, this isn't actually a circle. Looks like one. It's not. This is actually a spline that has handles, and those handles are at the top, bottom, left, and right, and it is done in such a way that it looks like a circle. So if I go into this thing here called Direct Selection Tool, it is showing me a center of this circle, but I can also select this point here. You'll see this handle shows up, and I can twist the handle, and now I very much don't have a circle. I can also, instead of twisting the handle, drag this point up. And again, I very much don't have a circle. Or I can move this over slightly to the side. And again, I very much don't have a circle. I can basically warp this into a variety of different like crazy shapes. So even when it looks like a circle, just keep in mind it's not a circle. So when I go into Fusion and I go and I import it, we're going to have some problems. Let's go and take a look at that. New design, insert DXF, choose a plane, choose the DXF file that we just made, the AI to DXF. We're going to choose our units, just like we talked about, and we're going to choose inches. And maybe I'm going to keep everything. Maybe I care about everything. And I'm intentionally, by the way, ignoring this control point frame thing. We're going to look at that in just a second. And I'm going to say, OK. Let's go and edit our sketch. Now, if I zoom in here, this looks like a circle, right? But again, this isn't a circle. Now, this looks like a circle enough that I can go and extrude this, and I'll have what probably, again, looks like a circle. But you'll notice that there's a line on the side, right? There's a little bit of an edge break. And you'll also notice that if I go into the sketch and I look at this and I kind of hover my mouse all the way around this, when I get to the right-hand side in this case, you'll see a point right over here. So this is, again, not a circle, right? Fusion is not reading it as a circle, but it looks like one, which means that if I'm trying to make another circle that is concentric to this one, maybe, oh, let's fix this in place so that it doesn't move on us. There we go. And I draw a new circle, and I want these to be concentric. Concentric isn't even an option, right? Because you have to make two circles concentric, and this smaller one is not a circle, as I mentioned. So one of the tricks that I like to use, and this is, I think it'd be helpful to all of you, is to recreate the circle in Fusion. And this is annoying that you have to do this at all, but it is true. And it's just based on the way that the file, that vector was created in Illustrator. So the way that I like to do that is first I fix the original geometry. Next thing I do is I add enough points to the geometry so that I have 3 points total. Let's go in. We already have one. You can see that one right over there. I'm going to say create a point, and I'm going to pick one right over here, and let's say one over here. And I'm also going to fix these because I don't want those moving on me by accident. And now I have 3 points. I can actually delete the original circle if I want to, but I'm going to show you, I'm going to leave it in place so that you can see it, so that you can see that this is going to be accurate. Right, so now that I have those 3, I'm going to go and say coincident. I get to pick this point and the circle, this point and the new circle, this point and the circle, and this is where it's going to be cool. It's going to all of a sudden be the right size. And now I have what looks like a circle, right? But this one actually is a circle. It has a center point and everything. Fusion reads it properly. But one thing that you're going to want to do at this point is you're going to want to delete the original, because what you don't want is for there to be some sort of minute, tiny difference between. And when you're extruding, you're grabbing part of the true circle and part of the not true circle. So normally I would delete the original circle first, and then I don't have to go and bother deleting it after, right? Because when you're selecting here, you have to wonder to yourself, are you selecting the original circle, or are you like the pretend circle, or are you selecting the true circle we just drew? Well, here's another trick. And you know what? This wasn't in my list, but now that I just thought of it, I'm totally going to add it to the list. So you'll see that in the description as well. But when I select and hold, a menu comes up that not a lot of people pay much attention to, but it's great. And this is going to let me pick things that are harder to pick. So I can pick an arc in this case. I could pick a profile, which I think is like the bigger sheet metal part, or I can pick a control point spline, which apparently has degree 3. And this is the imported circle from Illustrator, right? The arc is the circle I drew, and the control point spline is the one from Illustrator. And now I can select it. Visually, I still can't tell what I selected, but I know what I selected because I chose it correctly. And now I could hit delete. And now that one is gone, and I'm left with the true circle that I drew in Fusion. And now all I need to do is delete these points. And if I want to fix that circle in space, I select the circle and I use that fixed constraint, and now that's not going to move as well. Or I could put dimensions. Now, the slight alternative to what I just showed you
is going to be as follows. Let's go back a little bit. Okay, so here I'm at the point where I use the coincident constraint on these two points. I didn't do it on the third yet. Now I might go and just delete that original circle, right? Oh, I do have one problem. So in this case, I only added 2 points. I didn't add 3. This one's actually going to disappear once I delete the circle. So in this case, slight change in my plans, I am going to add a third point of my own, and we're going to go and fix that. We're going to go and add a coincident. We'll delete this one. There we go. Here's what I probably. Let's start from scratch because this is getting confusing, and I don't want to confuse. All right, so this is the original circle, exactly how it was. Let's go and add 3 points. This is really what I should have done from the beginning. Add 3 points. Lock them down in position. So fix them in space. Perfect. Now you can go and delete the original circle. You don't need it. You have those 3 points. Draw a circle. Make the coincident constraint with all 3 of these points. Now it's exactly the right size. Guarantee it. Now you could go and fix the circle itself and then go and delete those points. Now that sounds like a kind of like convoluted, crazy way to get to here, and it kind of is, but this is a great way, truly, I promise you, a great way to be able to turn your control point splines that look like circles into actual circles that are useful. This is exactly the way that I do it personally. Now, the other thing that I want to show you is the option that I didn't show you, I intentionally ignored with that control point frame option. So let's go and delete this sketch. Let's go and delete all this stuff. Let's import our DXF one last time. And now we're going to show you that option that we didn't pick. So let's go and choose the same exact file, the AI to DXF. We're going to make sure that the units are correct and they'll be inches. Oh, and by the way, heads up, based on the list that I have and the fact that we're already 45 or so minutes in, this is definitely going to be a long video, but I hope it's going to be action-packed, filled with a lot of good stuff, and that you enjoy it. All right, so we're going to leave all these options the same. This time, I'm going to turn on this button here that says Control Point Frame, and we're going to say OK. Here's where it gets really interesting. Let's go and edit our sketch and zoom in on those circles. Remember, Fusion interpreted that circle as a control point spline, right? Because it is, right? Go back to Illustrator, and you could see that this is a spline with a bunch of points that you can control, right? Actually, in Illustrator, it's more of a fit spline. But here, I have what they call a control point spline. What it added are these construction lines around the circle. And what this is going to allow you to do, if you want to, is pull on any of these that you want, and you can start to do those kinds of manipulations that you saw in Illustrator, right? You can warp this into funny shapes. So this is another interesting way to be able to modify your geometry. This is true for the circle example that I'm showing you, but this would also be true with a variety of other different shapes that are arcs, or at least look like arcs in Illustrator, that are really control point splines. You could change those shapes really quickly and easily by turning on that control point spline, control point frame option when you bring in your DXF file. So this is a great example of that. Now, the next item that I wanted to talk about is going to be lock and unlock. We already talked about it a little bit, but we're going to talk about it a little more. So let's say you're designing something, right? So let's start from scratch for a moment here. We're going to go and create some sort of shape here. I'm going to go and draw, let's start off actually, we'll go with vertical line, we'll go with a horizontal, and we're going to go and draw some sort of angle in between. This is super simple. I'm just trying to make this basic for us. Now, if I want to change the angle here, I know that I can go and select this corner and I can drag this in and it's going to just go and drag it in for me and it changes the angle. And part of the reason that this is happening is because this line at the bottom and this line over here, those are already constrained. This one's vertical, the first one was horizontal, and they're both locked into this corner. But what happens if I have another triangle like this one that's not as constrained? So let's go and put in this guy. And if I drag this one, it still does move, right? And it changes the angle. But I'm sure you've already experienced this, that there are plenty of times where you go and grab a corner like this. And what really happens is the entire line moves together, right? So another example, let's actually just go like this. I grab the line, right? If I grab the corner, it will change angle. But if I grab the line itself, it just kind of moves in, right? But that's not necessarily true if maybe the top is constrained. So let's try that. Let's go and put in a dimension for this vertically, some number like that. Now if I drag this line, it kind of freaks out. It doesn't want to move at all. Right? If I grab the corner, it changes angle. That's what I wanted. Let's delete this other stuff. We don't need it. All right, so if I grab this corner and I drag it in, it changes the angle. But if I drag the line itself, it doesn't do that. So here's a trick that you might want to use. So if you draw a line and you want to be able to move that line but have the angle change, but you're not ready to put in like dimensions to this corner or anything like that, all you have to do is fix the corner. And you could always undo that later. Not a big deal. So right click on that point and say fix. Or as a reminder, click the fix constraint and then choose the endpoint. It doesn't have to be the line itself that you choose. It could be the endpoint. Now that you've done that, now you can actually go and grab the line and you'll see it pivots based on that corner because that corner isn't going to move. So if I have some sort of picture in the background and I know that this is going to help me line this up, now I could go and line this up exactly where I want. And then once I have that good, then I can go and unfix the corner. And then I could put in my constraints, however I want to put them in, or I could actually fix the line itself. That's pretty handy, right? So that's a great way to be able to rotate things and be able to freeform it. Now you could also use the move command. We'll talk about that again later. But I think the fix command is underutilized in how you use it. And this is one of many ways that you can use that in I think, a great way. So let's talk about another use of that fix command, right? So let's say I have two lines. I have one like this, and I have one like this, and I want these two to actually meet each other, right? At the moment, those two lines, let's delete all this other stuff here, those two lines are not constrained, and if I try to do, let's say, a coincident constraint between them, it actually moved the line. That's not what I wanted at all. So maybe I'm going to go and try to extend, right? That's probably something you might try. I go to the extend command and I extend that line. Then I go and extend this one. That actually does give me what I want. So that's a great way to do it. But depending on how complicated your sketch might be, you might have to do multiple extend commands until it gets to where it needs to be. Then you might even overshoot it and then have to trim back. Basically, it could end up being a lot of steps. So here's another technique using the fix command, and I think this is really helpful. So I'm going to go and grab this line right here, right click and say fix. I'm going to grab this line, right click and say fix. Now I'm going to go and use that same coincident command or coincident constraint, and I'll pick these 2 points, and it can't move the lines. It can only extend them because the lines themselves were fixed. And now that I have what I want, I can unfix that line and also unfix that one. So depending on the circumstances, you now have more options of how to be able to achieve the same end result. Can you use the extend command? Absolutely. But now you can also see how you could use the fix command and also, in this case, the coincident constraint to be able to extend your geometry without moving it where you didn't want to move it. So that was the lock or unlock command. And we covered it, by the way, in a lot of different ways at this point. I hope you enjoy that. Now let's talk a little bit about slice. So let's go and use a different model because we don't have anything on our screen right now that is useful for this. Let's clean up our browser a little bit and let's jump to a 3D model. And we're going to start talking about drawing sketches on a 3D model. This one is still not interesting enough for me, at least right now. So let's go and grab something else here. Perfect. So I have a table that I think we're going to use for a little bit. Perfect. Okay, so this table is a pretty geometric table. It's pretty cool. I like this. And we're going to go and draw a sketch in the center plane. So let's go and find that. That's the XY plane. And we're going to go and draw a quick sketch on that XY plane. And I am interested to see what's happening here on the cross section. And in this particular case, the cross section happens to be flat, but there could be a cutout on this backside that maybe is important. Actually, let me just go and make a quick cutout, and then we'll be able to give you a proper example. So let's go and draw some sort of cutout. And we'll go and make this tapered. So now we have a cutout. Okay, let's do this again. We're going to go and draw a sketch on the right view, but I can't see the cutout at all at the moment. And maybe something I'm drawing right now is dependent on what's happening in the cutout. So what a lot of people are going to end up doing is they're going to create a cross section, right? You exit out of your sketch temporarily, you go to inspect, yeah, inspect. You're going to go to section analysis. You choose the plane that you want. It creates a section view. And then now you could go and create your sketch and you could see exactly what's going on here. Now, this analysis tool, right, for the cross sections is really handy. My favorite part about it is that you can leave them for a long time, right? I could actually have multiple cross sections. So if I have another plane, like maybe this one over here, I could also make a cross section of that plane. There we are. And then now I have one, and you can name these, of course. So we'll call this 2/3, and we'll call this midplane. There we go. So now I have the midplane and I have the 2/3 plane, and I could toggle back and forth between them, and I could have as many of these as I want. But what I really care about is when I'm sketching, I want to see the cross section of wherever I'm sketching. So here's a cool trick. I'm going to turn off my analysis tool here. We're going to go and make a quick sketch on that center plane. And you'll see here on the right-hand side in the sketch palette, there is a thing here, is a slice, and there's this checkbox. And a lot of people don't bother to like try out to see what all the checkboxes do. But this slice tool is great because it'll give you a cross-section of whatever plane you are drawing on right now. Right away, instant. You could turn this on anytime you want, right? So you can see it or not see it, and this makes it really handy. So now I could start to draw some sort of geometry. Maybe I want a hole that's going to go through this particular table, and I want it to be dependent on this particular area. Now I could see it. But keep in mind that right now, I'm just seeing it. I can't snap to it. So I am going to still need to use projected geometry to be able to do that. And we're going to talk about projected geometry in just a little bit, but the slice command in general is really useful, and I wanted to give you just a taste of it. We'll come back to this and we'll talk a little bit more about projected geometry in a little bit. Let's talk about control. And when I say control, I don't mean like being a control freak. I mean using the control command while you're sketching. So let's say you're in a sketch, and let's go and use this example. Let's go back to our tray for a moment. I have my sketch and everything is looking really good. And maybe I want to add some more geometry to it. So let's go and do that. So we're going to go back in here and I'm going to start to draw some new geometry. I'm going to hit L for line and I start to draw. And you'll notice that as I'm drawing, a little icon shows up just above my mouse. And that icon happens to be the same as this horizontal/vertical constraint icon. And it's telling me that it's going to go and give me that horizontal/vertical constraint. You'll see here, just like that. It shows up right over there. If I continue my line, you'll see that as I go horizontal, it's going to give me, in this case, not a horizontal constraint, but instead it gave me this perpendicular constraint. So what it's doing is it's giving me additional constraints as I'm drawing. And sometimes I like that. It's actually really handy if it gives me what I wanted. But if it doesn't happen to give you what you want, you can actually avoid creating these snaps or creating these constraints by holding that control button. Let's go and do the same thing again. And this time I'm going to hold the control button. So I select the first point of the line. As I go down here, it's showing me that it's going to create that constraint. But if instead I hold control, now, even when I go pretty close to vertical, it doesn't show me that it's going to snap anything. And then when I go horizontal here, again, it's not showing it's going to snap anything. And if I try to make this actually snap to this area, if I'm holding control, again, it's not going to snap. If I let go of control and then I hover over this area, it shows that it's going to snap to this region. And the reason I'd like to do that, not always, but sometimes, is again, if it's going to give me a constraint that I'm not happy with, I'm going to have to go and delete it anyway. Instead, I hold control and then it doesn't apply that constraint, and then I could just go and add the constraint myself. This one's going to be horizontal/vertical. This one's going to be the same. So control is your friend to be able to not snap things. That's a great tool. All right, let's continue. We also have a move command, and I said earlier we would talk about the move command. Let's go and do that right now. So if you go to modify, you'll find the move copy command, and keep in mind it will move stuff or also copy it, right? So let's go and give ourselves an example. So I'm going to start off simple. I'm going to go and draw a circle, something like that, and I want to go and move this somewhere else. We're going to go to modify, move copy, select the object you want to move. You'll see here that there are a lot of different move types. The most commonly used is free move, which allows you to go left to right, up and down, both at the same time, and also rotate. And a circle isn't going to look any different when you rotate, but you can rotate. You can also choose just translate, which will let you move just left and right at one time or just up and down. The free move, like that square option where I can move diagonally, is not going to show up here, right? Or I could choose to rotate only. And I also have these options for like point to point, which is great. I could pick like this point right here, and I could pick a place that I want it to go like here, and it'll just snap to that position, which is really handy. But everything I'm doing here is going to be for geometry that is not fixed or unfixed. Cannot move fixed or unfixed geometry. So let's go back. Let's go back to that other example. I shouldn't have actually closed it, I suppose. We're going to go back into our DXF. We'll just bring in this one right here. All right, so here I have my geometry. If I did what I recommended, right, I'd go into my sketch here, and I'm going to go and select everything, right click and say fix. And if I try to use that move copy command and I try to select this geometry, you'll notice that none of this is selectable. I cannot move it. If, however, I take some of the geometry, whatever it happens to be, like this one, and I unfix it, now I could go and take that and I could move it somewhere else. So if you're having trouble moving geometry, the first thing you should look for is geometry, is the fix or unfix constraint. That might be preventing you from being able to move your objects. The other thing that would prevent you from moving your objects are going to be constraints, depending on how many you have and what they are. So let's give you an example. Here I have that circle, and we're going to go and lock the position. Let's put a constraint between, actually, let's just go in, this circle is the funny, not real circle. Let's go and draw a real circle. And I'm going to go and put in a dimension from this edge to here, and I'll also go and put in a dimension for the diameter. Now you'll notice that I have enough constraints to keep this constrained left to right, but it can still move up and down. If I go and I use that move copy command and I select this circle and I try to move it left or right, this manipulator set will move left or right, but the object itself will not move. When I hit OK, you'll notice it did not move at all. If I go and grab that circle and I move it up or down, it will move, but the constraint is still overruling what you could do in the move copy command. So keep in mind, if you're having trouble moving something, that you might have too many constraints or dimensions or something like that, like fixed constraint or dimensions or constraints that are limiting your ability to actually move it. So if you truly want to be able to move it, the best way to be able to do that is just to get rid of all your constraints, just like that. Go back into that move command, and now you can move this wherever you'd like to move it. Cool. Now let's also talk about 3D, and this is where it's going to get really interesting. The move copy command will let you actually move things not just in 2D on the plane itself, but it will also let you move in 3D. So if you rotate around here like this, you'll see that those manipulators are not just in like the X and the Y, they're also in the Z. I could actually move this up in the Z direction, and now I have a 3D sketch. And to be clear, that is true even though this 3D sketch button or checkbox is not turned on. What I want you to think about for this 3D sketch checkbox is whether or not when you're creating something, it's going to allow you to create 3D geometry. But the move command will still allow you to be able to move things in 3D. So let's actually take that further. We're going to go and select everything that's in this geometry here. I'm going to go and unfix it. And I'm going to go back to that move command. And you'll also notice that you could even move points. So I think I misselected. Let's try that again. That point right there. And I could go and move this up. And based on the constraints that you're going to see with the rest of the sketch, it's actually going to go and manipulate the geometry based on that. So you could move things in multiple directions, and you can move them up and down. And again, the 3D sketch checkbox is not turned on, but if you are choosing to move in this Z direction, it will create a 3D sketch out of your 2D sketch. So that's how move works. The only thing I don't think I showed you is that you can select an object, and you can hit this checkbox for create a copy. And then when you go and move, it's actually going to create a copy and move the copy. So that's another thing to keep in mind as well. But the move command is fantastic. And remember, if you have scenarios like the triangle that I was showing you earlier, where I have, let's say, a line like this and I want to be able to rotate it, what I showed you earlier was fixing a corner and then being able to rotate like this. The other thing you could do is you could use that move copy command, select the line itself, choose to rotate, and you are going to have to choose an axis of rotation. And unfortunately, you can't pick an axis that is like the point on the line itself. So in this case, I would pick, let's say, the z-axis, and I can rotate that sketch as well. But I don't, in my, just my personal opinion, I don't think I have as much control over the pivot location as I do by just fixing the pivot location and using that. So that's why I like the fix command for it. The alternative, if you really wanted to, is you could create, if you go to, let's see here, if you go to like the solid geometry tab under construction, you could create an axis that is, straight, that's like parallel to the z-axis at this point, and you could use that axis for the rotation, but then you're adding a whole bunch of extra steps, and I don't really care about the axis in the long run. I just care about, getting the geometry that I want, which is why I like to do the fix the corner and then rotate the line around where, drag the line until I'm happy with it and then unfix it. But if you did want to, you could select the line, use the rotate tool, select an axis, and then you could also rotate that line wherever you want. So that's the move command. Let's talk a little bit about patterns. All right, so let's go into our tray example. All right, so here I have a tray. Actually, let me show you the finished one. And you can see I have a pattern. This is a linear pattern. You take this shape and you pattern it across to the side and then down, and you'll have whatever shape you want. Now, if anyone has ever had problems with the pattern command, I have two tricks for you that I think you're going to like. So let's go into this example here where we're just starting out. Let's make this all way bigger so we have some room to play here. Oh, let's put in our dimensions. And we're going to use that same trick for our dimension. Oh, let's go. We have to go to our sketch. My mistake. Let's go and add a tangent dimension from here to here as well. We'll set that to like 10 millimeters. That's looking pretty good. Let's go and drag this to be way bigger. Oh, we forgot a diameter. Oh, wrong one. Let's get rid of that. Try again. There we go. Now we have a fully constrained sketch here. And we're going to go and add quite a bit. So we'll go with like 1500. We'll make that way longer. This will be like 1000. Way bigger. Okay, so now I have room. So let's talk about patterns. First thing is that if you don't have to do a pattern in a sketch, I don't recommend you do a pattern in a sketch. You can if you need to, but just so you know, the amount of resources it takes to be able to do a pattern in a sketch is a lot more than a pattern of a feature or a pattern of a body. So I try to limit my use of pattern sketches, but if you want to do it, you can do it. Here's the trick. You go to rectangular pattern, choose the objects you want to pattern, like this square thing. We'll just go and select the whole thing, just like that. Perfect. Now you'll notice that I have these two arrows, and sometimes people get confused about like which direction is which. So the key is that when you go to the direction, instead of using the default, I like to pick it myself. But you don't just pick one direction, you pick two directions. If you pick just one direction, the potential is that the second direction is not the axis that you think it is. So right now I'm picking the X, and I did not pick a second thing. And I have the feeling for this one it's actually going to be correct. Yeah, it's going correctly, and that's fine. But if you've ever had the case where it's going, the first direction is what you wanted, and then the second direction is like up out of the screen, and that's not what you wanted at all. The reason is because when you go to pick your direction, you can pick two directions at once. And I do recommend you just do that from the beginning. So let's go and do that. I'm going to go and select this edge, and I'm holding Control, and I'm also selecting that second edge. You'll see here, it says two selected. That guarantees that this is going to go in the two directions that you wanted. In this case, left to right and up and down. And then you can select whatever you want for your extent or your spacing or everything else. So the trick here, it's the two tricks that I was really referring to is number one, if you don't have to pattern in a sketch, don't. That's the trick. And number two is that if you are going to pattern in a sketch, always select both directions. That'll guarantee that you always get the directions you want. And keep in mind that the directions do not necessarily have to be perpendicular to one another. So let's go and cancel this for a second. We're going to go and draw some sort of funny direction like this. And maybe I'm going to go and pick an angle between this. And we'll set that to be like 15 degrees. Cool. We're going to go and select this rectangle. And we're going to say create a pattern. We're going to select for a direction this edge and this edge. Now I'm going to be able to go this way, and I'll also be able to go that way, right? So you can pick two directions. They do not have to be perpendicular to each other. But again, I always recommend picking two directions. You can set this to be 0 as your distance, or you could set this to be 0 as your quantity. But generally speaking, I think it's a good practice to, oh, quantity can't be 0. Sorry, distance can definitely be 0. But I do recommend always picking two directions. So you have 3 tips there. Try not to pattern sketches if you don't have to. Try to pick two directions. And then what was the other one? I already forgot the other one. I'm just going to move on. Too much. This is a lot of stuff to go in one live stream. Right? So we covered quite a bit there. Now there are 2 different kinds of sketch patterns that you can do, right? You can do your rectangular pattern like I just showed and your circular pattern. Circular pattern is absolutely perfect for, circular parts, like anything that you're going to end up doing like a flange, circular flange or something like that. Pretty common. The other thing that you can use circular patterns for is trying to get something that is on the opposite corner. So like if you wanted something that is mirrored across and then down, but you don't want the top right corner, you could actually also use a circular pattern. So watch this. We're going to go and grab this rectangle. The center point in this case might be like this point right over here. And we're going to say, let's go all the way around, but I don't want 3, I just want 2. And that'll give me this corner right over here. And before you guys start typing in that I could also have put in a line over here, and set this to be midpoint. And I could set this to be whatever the correct angle is here. I probably picked wrong. Let's do this again. I could pick whatever the angle should be here. It's probably 45, but it might not always be 45. The key though is that you could get a very different result if you're doing the mirror across versus circular pattern across. Because if you remember, circular pattern is actually rotating around versus mirror is direct mirror. So depending on your application, I do urge you to consider a circular pattern to be able to get something across like that and still have the orientation be exactly what you want. I think that's really helpful as well. All right, so that covers most of patterns, but there's one more pattern left. And I'm going to put you guys to the test. So if you go here, you could see rectangular pattern and you could see circular pattern. Can anyone on the screen right now see the pattern on a path? Maybe, probably not. You guys are probably scrambling to look for it right now. Well, pattern on a path is incredibly useful, but you will not find it in the sketch palette. I'm still going to put it in this video because I think it's helpful for when you're creating sketches and everything, but it is not actually in the sketch toolbar. So if you want to find that, you're going to have to go to the solid modeling menu, create, and if you go to pattern, you're going to see here pattern on a path. And this is incredibly useful, especially for things like stitching holes. So let's give you an example. We showed you quite a few times this sheet metal part that we started to butcher in this example. And I'm going to show you what it looks like in 3D. So let's go and grab that. And not this one. Let's go, yeah, this one. Let's say instead of making this out of metal, I wanted to make this out of paper or cardboard or leather or anything else. And I want to be able to actually stitch this together instead of welding it together. Well, one way you can actually do that is using pattern on a path. And so let me show you the example that's already done. Pull that up. And this is what it looks like with some holes in it. And the best way to create this is using the pattern on a path approach. So the way that I did this was I unfolded the sheet metal part, just like that. I created a quick sketch. Let's go one step forward. There we are. So I created a quick sketch where I projected the geometry of the overall shape. I then used an offset. Actually hide the body for a second. I use an offset so that I have this 1/4 inch from the outside edge. I also made a little bit of a change here so that the hole wouldn't end up being on the very end here. So I have this overall shape, right? Then I create a quick sketch that shows the actual hole that we're going to go and create. That's the hole right over here. And then I extrude the hole out of my body. Let's go and show that. Let's hide my sketch. So at the moment, I only have a single hole. And then what I did was I do pattern on a path to actually be able to have this go follow the path itself. And then I used a circular pattern to be able to mirror this across all 4 corners because this part happens to be symmetrical. Remember, the pattern tool actually works better when you use it not in the sketch, when you use pattern features and things like that. So in this case, I'm doing the pattern on a path, which I can only do in 3D. Then I did the circular pattern, which I could do in 3D or as a sketch, and I prefer to do it as a 3D. Let's go and look at that pattern on a path for a second. What you'll see here is, again, the feature that we're going to be patterning is the whole feature. You'll see that right over here in my timeline. And then the path is the sketch that I created. The key here are a couple of things, and I want to set you up for success. I'm setting this up as extent. And so this distance that you see here needs to be the length of the actual sketch, like the path. And then the next thing is that I pick the quantity of how many holes I want here. And I could set this to be anything I want here. And I do have this checkbox to turn on or off certain holes that I want or don't want. So if I don't want these ones that are too close to, let's say, this bottom, I just uncheck those and hit OK. And that's giving me exactly an updated path. The trick, though, is you do need the length of that path. And if you put that length in correctly, this is a great way to be able to create holes for stitching or for any number of other things. And again, I'm including this in our tutorial about advanced sketching, but just know that this isn't actually a sketch tool, but it is there. All right, we are an hour and 20 minutes in, and we still have quite a bit more, 4 different things on our list, and I'll tell you what they are. We're going to talk about project versus intersect, which I think is commonly confused. We're going to talk about intersection curve. We're going to talk about project to surface, and lastly, we're going to talk about 3D sketching. So I hope you still have some energy left and some concentration left. We're going to jump right into project versus intersect. So let's go back to our table example. Now, if I were, let's actually delete some of this extra stuff we don't need. We don't need that, and we'll suppress this for now. Okay, so if I want to go and create a sketch that is on the center plane, all I do is pick my center plane, that would be the XY plane, create a sketch. And if I want to be able to see this as like a slice model, again, I could turn on that slice tool. It's pretty cool. Now, most people end up using the project tool. Under create, project, P for project. You probably notice that there's this purple option and then also the gray option. Perfect. The purple option lets you pick specific things that you want to project. So if you want to project a point, you pick the point. It'll end up being a point on your sketch plane. You can also pick a line. I'll actually pick a different line so you can see it separately. You could also pick a face, and it will give you the projection of that face onto the plane that you're drawing, right? So let's go and look at what we have. I'll hit OK. We'll hide the body for a second. We have a point and we have two different lines. And again, these are based on the vertices, the edges, and then also the faces that we selected. Let's go back here and also and edit this again. Let's delete all this. And we'll go and look at the other option, the one for project a body. Now, projecting specific entities is helpful if you want a very specific thing. But if you are trying to project the entire object, you don't want to have to go and select all of these edges and everything else that could be very time consuming. The project bodies option is a great way to not have to do that. So let me actually clear my selection, choose the bodies option, select anywhere in the body I want, hit OK, and now it has the entire body. Now this is actually two benefits. Number one is that was really fast. I didn't have to select a whole bunch of stuff, I just selected one thing. The second benefit is that this is actually more robust than selecting a specific object. More robust meaning that when I change my table design, I change the height, I change the width, I change whatever it is I want about this table, it's less likely to fail later on in my timeline. Why, you may ask? The reason is because when you end up projecting an edge or a vertex, keep in mind that that edge or vertex may not exist based on the changes that you made. So maybe you make a cutout in your design, and now that cutout eliminated that vertex. It doesn't exist anymore. So what do you think is going to happen with your projection of that vertex? It's going to fail because it doesn't know what to project anymore because that thing doesn't exist. But what's likely to stay, no matter what you do, is that body. Because after all, that body is something important to you. You're designing the table. The table is still going to exist, or is very likely to still exist. So projecting a body is way more robust than projecting a face or an edge or a vertex. And I try my best to always project bodies if I can. There are plenty of times where I intentionally project just one thing, but I know while I'm doing it that the trade-off is that it's less robust. So keep that in mind. The other thing you should know about project is that what it's doing is it's giving you a silhouette. So right now you could see I have the silhouette of our table, right? But if you remember, I ended up suppressing a extrude cut through our model. So let's actually go and let's hide our sketch for a second. Let's turn on our suppress feature. Here we are. So now I have a cutout. And if I go and I look at that sketch of what we just created, you'll notice that the sketch itself doesn't change. That's actually kind of surprising at first because I have a cutout here. Why is the sketch not changing based on it? Well, the reason is because the project tool is actually projecting a silhouette of the overall outer perimeter of whatever that shape happens to be. And so it actually doesn't see this cutout because that cutout isn't there. If the cutout stuck out, it would end up including it. Let's actually do that. I'll show you what that looks like. Here we are. We're going to go out and we're going to change this to join. And now you could see that the projection includes that area, but the cut in it did not see because again, it's really the silhouette that it's looking for. Now you could get a very different result though if you're using the intersect command. So let's actually go and put this back to where it was. So this is the cut. And we're going to go and we're going to also go and take that midplane. And let's go and grab the XY plane, create another sketch here. Let's turn on our body. There we are. And this time, instead of using the project tool, let's go back to the project or include folder, and we're going to choose intersect. And this one is, in my opinion, even more useful than the project tool. I probably use intersect more than I use the project tool, even though I think for a lot of people it's the other way around. I really like the intersect tool. So again, I can select any edge or vertex that I want. So let's actually let's hide the original sketch, the last one that we had. All right, so let's only show the new one. If I pick this face, it's going to show me the intersection between the sketch plane that I'm on and the face that I selected. And that is going to end up with a line in this case. If I pick a vertex, it'll, in this case, give me a vertex. If, however, I pick an edge over here, out here in 3D space, guess what it's going to give me? Big fat zilch. Because guess what? This edge does not cross the plane that I'm actually sketching on, which makes sense, right? So keep in mind that the intersect tool is really just giving you the intersection. And if you're choosing specific edges or entities to be able to intersect, choose wisely because it's going to give you or not give you based on what it can actually achieve. But if we clear that selection and I use the bodies, which is, remember what I told you I always recommend, I'm going to go and choose that body and hit OK. And now let's go and hide the body and show the sketch. This one actually includes the cutout, and the one before doesn't. Right, so the one before with the project tool is giving me the silhouette, and the one with the intersection is giving me the actual intersection. So to me, this is incredibly valuable and incredibly useful. I recommend you actually go to the project or include and come up with a shortcut that you should use for yourself. Right, I is typically for inspect, so maybe choose something else. Maybe it's like Control I or something like that, like I'll pick. And now from now on, Control I is going to be the intersect tool. So that's pretty handy. Let's take it a little further, actually. So we're going to go and create another new sketch and show our body. We're going to say, create a new sketch, pick a plane. And this time, we're going to go and use the include geometry. So project, and we're going to choose include 3D geometry. Now, what include 3D geometry does is it's like a projection in place. It does not move it. It's kind of also like an intersection in place, but it's not intersecting anything. It's really just intersecting itself. It just, so I guess more like a projection. But the key is that it's in place. It does not move. So if you use the include 3D geometry and you pick something that's on the plane that you're drawing on, it's going to look exactly like the intersect tool would or like the project tool would. Nothing super special there. Let's go and undo that one for a second. Let's do that same thing again. But this time, we're going to go and pick an edge that's off in space, that's not in the plane that we're sketching. So if I choose this edge over here, or I choose this edge over here, or choose this vertex over here, let's go and show you what we have. Let's hide the 3D model. And what you're going to see is stuff that are not in the actual plane. So if you could see here, this is the plane that we're drawing on, the XY plane, and the rest of this stuff is off at a distance. It's off in space. Now keep in mind, again, that the 3D Sketch button was turned off, but yet it created 3D geometry. And it's because the include 3D geometry only does one thing. It creates 3D stuff. So regardless of whether 3D Sketch is turned on or not, it still will do exactly that. So include 3D geometry is great for being able to like highlight an edge in exactly where it is. So that's really handy for a variety of reasons, but like this is one of them. If you want like a more organic form or more aesthetically pleasing form, I'll go and grab, I think, one more example of this, and then I think we'll move on to the next topic. So let's go with like consumer products. I think there was a cool leaf blower we're going to use real quick. All right, perfect. So let's say I'm trying to do something with this like plastic housing. And I want to go and create some sort of like lofted, going to make a groove that goes across here. And I want that groove to be nice and smooth. Now, I'll admit, like, the edge transition here does not look ideal for what I'm trying to do. So we'll probably make our own. So maybe I'm going to go and say create a sketch. Choose a plane. You always have to choose a plane regardless of what you're doing and like where the 3D sketch is actually going to be. We're going to go to create, project, include 3D geometry, and I could choose this edge here and this edge. And again, it's actually going to just go and project those in space exactly where they are. Now I could go and say create a spline, and I'm going to make a spline between this point and this point. But you'll probably notice that I'm having trouble snapping to these two different places. And this is where the 3D sketch checkbox really comes in handy. Because remember, the 3D sketch checkbox is going to allow you to be able to create like a 3D sketch of your own. So now that I turn that on, I can snap directly to the ends of this spline, of those two splines or arcs. Oh, I misselected. Try it again. Do it one more time. I can select the endpoints of those splines and hit enter instead of escape on my keyboard. Then I could also go and apply constraints and make those tangent and make this tangent. Let's try it one more time. Perfect. And this is a nice smooth transition between the two. Now I could go and create, let's say, a construction plane along a path. And I'll go and turn this on, set this to, let's say, 0. I can go and create whatever my groove is going to be, draw this. Let's not make that in 3D, actually. Let's just draw that in 2D. Make whatever the size is. Oh, and let's rotate around so we can see it nicely. Make this maybe 125 inches. And then I could go and do a sweep across this. And let's go and do a sweep of this particular profile along this path. Perfect. All right, so that's the general idea. It just wasn't visible. I will turn that back on. Let's do that one more time. Body, create my sweep, pick my profile, my path rather. There we go. Turn that on. And now I have my profile wrapping around this particular body. So the point here is simply that the include 3D geometry is a great way to kind of project in place exactly what's already there. And then you could use the 3D sketch to actually be able to link them together and make a smooth transition. This one happens to not be very pretty. I'm not happy with it, but generally speaking, this is exactly what you're going to do. And that's a great use of, again, the include 3D geometry. Now let's go back to the table example and let's talk about the other two options that were there. Let's go and show our body here. There we are. We're going to delete a bunch of this stuff we don't need. There we are. There we are. Perfect. Okay. So next thing I'm going to show you is going to be in our sketch tools. Let's make another sketch. Create, project, project to surface. If you've ever wondered what this does, you're about to see. So project to surface is going to take a sketch that you've created and project it onto the face that you pick. So in this case, maybe I'm going to pick this face of the table. I'm going to go and choose the curve itself. And you'll see here that I have two options. I have a long vector, which is going to, you pick a vector, in this case, maybe it's the vertical direction, like that. And it's going to project this shape onto this particular face, directly up. Now, this is actually very similar in this particular case to the intersection curve. Let me show you why, and then we'll go back to project to surface. So let's hide this result for a second. So exit out of that for a moment. Suppress it. There we go. So if we go back and we say create a new sketch, we're going to go and say create project intersection curve. This is going to let me pick the curve itself and then the curve or face you want it to go to. This is automatically going to be normal to the sketch. And you'll see that this shape that just showed up is is actually identical to this one that you see here. So let's toggle them back and forth. This is the one that I used in the first case. This is the one in the second case, and they're exactly the same. The difference, though, is that the first tool that I started to show has way more options for how you could actually create it. Let's go back here. If you notice, when I was doing my project, let's actually go and delete this for a second, and we'll do it one more time. Create, project, project to surface. Let's do this one more time. So I'm going to choose, this is the face I want to project it onto. This is the curve, right? You'll notice that even if with a long vector, I get to choose a different direction. So I could choose some sort of funny angle, and it'll project using that angle, whereas the other tool, the project to surface, is only normal to the sketch. So already I get a lot more control here of the direction that I want to use for the projection. I love that. But in addition to that, I also get to choose closest point instead of a long vector. And closest point's really interesting because it's kind of like wrapping the sketch around. Now, this is not, just to warn you right now, this is not a true wrap sketch feature. So if you're trying to put text on a cylinder, This will get you pretty close, but this is not exactly what you're asking for in that case. But this is going to be pretty close. This is going to allow you to say, you know what, I want to take this sketch and I want to wrap this onto the surface using the closest point. And when I hit OK, I get a similar result. But what it's really doing is it's taking like this portion of my sketch and actually like twisting it based on the proximity of that sketch to the face, whatever's closest. So you can get some pretty wild and crazy results here. If you've never played with this particular tool, I hope just seeing it in action, even just a little bit, is going to give you a good taste of what you could do. So again, remember those tools I just showed you are all under this project or include dropdown. The project tool is used a lot by a lot of people. Intersect should be used a lot more. I hope you do use it. The include 3D geometry is going to project geometry in place, and then project to surface and intersection curve are very similar. In my opinion, intersection curve is kind of like the more basic of the two, and project to surface is much more advanced and gives you a lot more control over exactly how you're projecting and things like that. So those are some pretty cool tools. The last thing that we're going to talk about, and I'm only going to touch on this for a couple of minutes because we're already at, I don't know, an hour and 40 minutes in, and you guys probably need a breather after all of this. But we're going to talk a little bit about 3D sketching. You've probably already watched Tyler Kirkara's video on 3D sketching a bumper for a ATV, and it was a fantastic video. I'll put a link in the description so that you can watch that as well. But let's talk a little bit about 3D sketching. Now, you could have 3D sketched for a long time in Fusion, but the capabilities were a lot more limited than they are today. And the way it would work is you would create, I'll tell you how it used to work, just for comparison. You would create a 2D sketch. You would draw, let's say, a rectangle. Then you'd use the move command, just like I showed you earlier, pick a point, and then move it in space. And if you wanted everything else locked down, you would actually go and you'd lock down those positions. So let's actually go and do that real quick. Let's go and grab, let's say, these three corners. There we are. Now, Now we'll go and move just this corner right here, and I'll move this up in space. Oh, we have some constraints stopping us. Let's go and fix that. This guy, try it one last time. You would move this up in space. The problem is you wouldn't be able to constrain that position. And now with the new update that we have in Fusion, you can not only create geometry in 3D, you can also, like without having to use the move command to actually move it around, you can actually create it from scratch in 3D. You can also go and dimension as well, which I think is really helpful. So you can now go and dimension this in 3D too, which I think is amazing, right? So a couple of words of wisdom in doing this. Let's start from scratch. So we have our sketch. If you want to create your model in 3D, in Sketch in 3D, turn on the 3D Sketch toolbox. Once you do, and you pick whatever it is you want to create, you'll see this triad thing show up here. And the triad allows you to be able to change like the orientation of where you're designing. So you can rotate this in a variety of different ways. And basically though, you are drawing on a plane. You just have to choose which plane you want to draw on and the orientation of that plane. And then you go and draw your line. And you can put dimensions on that right away. And a word of wisdom again, or best practice, is to put dimensions on right away. This will make your life a whole lot easier as you're doing this. So go and put your dimensions on right away. And I'll cancel that one. Then I'm going to go and draw another line. So this time we're going to go and draw from here. As soon as I click there, again, I get that triad. I can choose the direction of that triad, and then I can go and draw in that direction as well. And I can keep going. I can keep going in any directions I want, whatever it is I'm trying to do. Again, I do recommend you go and put your dimensions in as early as possible so that everything will update nice and easily for you and not kind of break or blow up on you. Now, one of the coolest things about the 3D Sketcher that I've seen here as compared to other software that I've used in the past is probably the fillet command. You can fill it in 3D really easily inside Fusion. And that used to be very difficult for me to do in other software. So play around also with that fillet command. This is a great way to be able to make smooth transitions with, like tubes and other things that you might be creating. And this is a fantastic way to do this. Again, the 3D sketching is incredibly powerful and you could use it for so many different things. So like in this particular case, maybe we're going to go and use it to sweep something, right? So I can go and draw a profile, sweep through this, and I have a tube, kind of like in Tyler's video. Also, you can use it to create lofted geometry. Tyler used the same example I'm about to show you. You can go and create a quick sketch. And as long as the 3D is turned on, you can go and draw, let's say, a vertical line and make different segments, just like this. Then you could go and draw different shapes. In this case, maybe it's going to be a circle right over here. Maybe it's going to be another circle right over here, and then this will be a bigger one, and then this one will be a much smaller one. And so what used to take multiple different steps of creating different planes and creating sketches in different planes and projecting other sketches into that new sketch so that you get all the dimensions right relative to each other, I could do all of this in one place. So I could pick my dimensions to be, this will be 50, this one here will be 85, let's say. This one here is going to be 25. I could pick my height between them. We'll make that, let's say 35. We'll make this 25. And again, you'll see that my sketch is becoming fully constrained in just a matter of seconds. Now I could go and do, let's say, a surface loft, or maybe I'm going to do a solid loft. And I could loft between this profile here to this one to that one. And I could also change my end conditions and everything like that. I could also go and shell this out and give myself a uniform wall thickness. And now we have a beautiful vase or a beautiful part. All of this was done, though, with a single 3D sketch, a single loft, and a shell command. And that is absolutely phenomenal using the 3D Sketch tool. So play around with that tool as well as all of the other tools I've shown today. Again, we went through a giant list. Just to repeat that list for you so we could summarize here. We talked about how less is more, how you could design half or even a quarter of your design if possible. You can make your dimensions based on other dimensions or based on equations, based on items from your parameter table. Those items are parameters, of course. You can make your dimensions based on fractions or even feet and inches or feet, inches, and fractions. You can make your dimensions based on diameters. You can make them based on tangent conditions. And then the rest, I would say I'd group together as kind of a random smattering of fun stuff. But you could see that setting up 3 canvases as underlays for each plane could be really helpful. Inserting DXF as opposed to DWG or SVG whenever appropriate can be very helpful. You also can see that bringing in vectors from other programs like Illustrator and others, I'm not picking on Illustrator, Illustrator is a fantastic program, can yield some problematic issues. And you can redraw on top, which was using the fix constraint, I think is our option. You can also edit using the control point frame option. That lock or unlock is handy for a variety of different kinds of changes. But keep in mind that they do prevent you from being able to move your items using the move command. I showed you how to use slice in your sketches. I showed you how to use control to avoid snapping or to avoid adding new constraints. I showed you how to use the move command, both for 2D as well as 3D moves. I showed you how you can make different types of patterns, including one that's not exactly in the sketch tools, but I think is really helpful. I showed you the differences between project and intersect. I showed you intersection curve and what they do. I showed you project to surface and what that does. And lastly, I showed you 3D sketching as well. We covered a whole lot of different things today. And I hope you take what you learned today and use it. Remember that sketching is the foundation of all things 3D. So if you can master sketching, I think you're going to master the really important building block to get to everything else. And it's going to set you up for success in building your 3D models. So just remember that with Fusion 360, you can make anything. It's just a matter of time, patience, and effort. I hope that you enjoyed this live stream. Thank you very much for Brad for being on the keys today. And thank you for watching. I hope you have a great day.